I show quite a few people, I think there's 7 of you, have not done the test yet. Now remember, the tests are worth 50% of your final grade. If you take a 0 on the test, it's going to make it very difficult to pass. Okay, what we're going to do today are exponents. Now, exponents are very important. Now, exponents are the little number that's above, it's a superscript, it's above the regular number. So if we have 5 squared, this is called, the 5 is the base number. And the 2 is the exponent. Now, what does this mean? It means how many times, the exponent means how many times do you, doggone it, what did I just get through saying? Bring your drink, turn the recorder on, and get the microphone over here where it's supposed to be. Stupid boy. I'm tired of this being stupid. Okay, what the exponent does is says how many times do you multiply the base number times itself? This means we multiply it times itself twice, 2 times. If you forget, your brain goes numb, put it in the calculator. It'll do it for you. So if we have 4 cubed, okay, to the 3rd power, that means 4 times 4 times 4, which is, I think, 64. 4 times 4 is 16. 16 times 4 is 64. Okay? Again, the exponent tells you how many times do you multiply the base number. The base number is the bottom number, the big number, times itself. Okay? Now, if you look, what's the exponent on the 5 here? They're 1s. We just don't write it. But when we have the same base number and we're multiplying, we add the exponents. So this is actually equal to 5 squared. 1 plus 1 is 2. So if we have a squared times a cubed, now again, we have the same base number, a common base number, so we add the exponents. A to the 5th. I think I sent you a sheet on this last week. Okay, but again, you have to have the same base numbers. If you have a to the 5th times b cubed, there's nothing you can do here. We do not have, excuse me, we don't have a common base number. So this is going to equal a to the 5th b cubed. Now, the proper way to write this, I'm not going to be real critical about this, but you are going to find somebody at some point in your lives, at some part of your academia, that will require you to do this the right way. And that is largest. Does it make any difference whether we go b cubed a to the 5th? Not really. But somebody, the right way to do this is largest exponent first. Like I said, I'm not really real wild about this, but you will find someone who is, because it is the right way to do it. Now, what if you have c to the 5th times d to the 5th, where the exponents are the same? Then it goes alphabetical order. So this would be equal C5 D5. Okay, if they have the same exponent, but again, that's not super duper whiz bang important. Okay, so if we have b cubed times b to the fifth, common base number, so this is going to be equal to b to the 3 plus 5, excuse me, 5, which is b to the 8th. When you have a common base number and you're multiplying, it has to be multiplication, then you add the exponents. All right? Okay. Now if we have this, we have c to the fifth times d to the fourth times c cubed. Okay, we have a common base number here and here. So we're going to add the exponents here. So this is going to equal to c to the 8th, d to the 4th. This is real simple. There's just a few rules that we have to follow. Oh yeah, before I forget, this isn't going to make a whole lot of sense right now, but any number to the 0 power seems like it ought to be 0, doesn't it? Well, it's not. It's 1. And I'll explain this more later when we do division. Okay, any number to the 0 power is 1. Okay, don't write this down, just watch. You're probably going to see this on the final exam. If you have open parentheses 3a cubed plus 4b to the 5th minus 3c to the 4th, blah, 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 all raised to the 0 power. Now remember, what do the parentheses do? Makes this one number. So this is all of this raised to the 0 power is 1. But I tell you, you first look at this, or I do anyway. I see this great big thing here. Oh my God, what in the world are we going to do here? And then you see it's all in parentheses raised to the 0 power, so it's going to be 1. Remember, the parenthesis makes this one number. All this misery in here is one number. Raised to the 0 power is nothing more than 1. This is one of those things that doesn't make a whole lot of sense right now. When we get to division, it will. Now, what if we have this? What if we have 3m cubed in parentheses times 5m to the 4th? So we're going to multiply this number times this number. Don't forget to multiply the 3 and the 5. 3 times 5 is 35. No, 15. I knew that. And we have m cubed times m to the 4th is m to the 7th. Okay? You look at these, you think, oh my goodness, I can't do this. This is too hard. It's real simple. Just don't forget to multiply the coefficients here, the numbers in front. 3 times 5 is 15, and so forth. Okay, now addition, subtraction. You have, in order to add or subtract, you have to have the same exponent and the same base number. So if we have 3x to the fourth plus 5x to the fourth, are these like terms? Are these common, or these terms, are they alike? Yes. Have the same base number, and they have the same exponent. So this is 3x's to the fourth and 5x's to the fourth. That's 8x to the fourth. But again, they have to have the same base number and the same exponent. Okay, what if we have 3a to the fifth plus 4a to the sixth? Can we combine these two things? No. They're not they have the same base number, that's right, but the exponents are different. So what does this equal? It equals 3a to the fifth plus 4a to the sixth. Actually, that should be 4a to the sixth plus 3a to the fifth. Largest exponent first. Okay, they have to have the same base number and the same exponent. And this is if you're adding or subtracting. Okay? Okay. Now that was called the product rule. That's because we were multiplying. Product is the answer you get when you multiply. Okay, this is called the power rule. The power is if you have a number and like 2/3 all squared. This is kind of like the distributive property for exponents. This is going to equal to 2 squared over 3 squared. I'm going to multiply each one of these things by that. It's going to be 4 over 9. Or you can think of it like this. You can think of it as 2/3. This is one number here, right? Times 2/3 times its own self twice. Okay, you can do it like this also, which is, and when you multiply fractions, it's straight across. No common denominator. Excuse me, 4/9. I think it's probably better to think of it like this because these numbers are going to get a little bit more complicated than this. But you can think of it like that. It's the same thing. So what if we have this? Y over 3 all squared. This is going to be equal to y over 3 times y over 3, which is y squared over 9. Or you can think of it as y squared over 3 squared. Put the exponents over each one of the terms inside of the parenthesis. Okay, now what happens if you have a power raised to a power? What if you have x cubed all squared? Now when you have a power raised to a power, you multiply the exponents. Okay, because what is this really? This is x cubed times x cubed. Okay, the base number is this. We're multiplying it times itself. Same base number, so we add the exponents here. But again, what you want to do is you want to think about when you have a power raised to a power, you multiply the exponents. So if you have a to the fifth over b cubed, all raised to the fourth power. This is a 4. Okay, what do? We multiply the exponents here. When you have a power raised to a power, you multiply the exponents. So that's going to be a to the 20th over b to the 12th. We multiply those and that one. Let's see, what else? Okay, let me do another one of these.
Mr. Ball.
Yes, sir.
Do that again. Okay.
I'm gone. That's what I was just about.
Oh, okay. I see. Okay, I got you now.
Okay. Okay. When you have a power raised to a power, again, this is called the power rule. When you have x cubed over y to the fifth, all raised to the fourth power. Okay, when you have a power raised to a power, you multiply these two. So this is going to be x to the 12th, 3 times 4, over y to the 20th. Okay, power raised to a power, you multiply. Did y'all get that sheet I sent you? I think I sent it last week on how all this stuff works, but if you look at it, it doesn't make a whole lot of sense when you first look at it. Hopefully it'll make more sense now. Let me do another one of these. When you have 3c squared over 5d to the fourth, all squared. Remember, you have to square everything in here. So first of all, let me kind of break it down into, it's going to be 3 squared. Okay, don't forget the exponent on the 3 and the 5 are 1s. We just don't write it. Times c to the 2 times 2. Because you multiply the exponents. 5 squared times d to the 4 times 2. Okay, we multiply the exponents here. When you have a power raised to a power, you multiply. So 3 squared is 9. C to the 4th. Okay, 2 times 2. Okay, 2 times 2. And this one's going to be 25. D to the 8th. Can we reduce this fraction? No. Always look for this. On the final, you're going to see something here that's going to be, you're going to be able to reduce that fraction. Okay. And what if we have this? What if we have 5e to the 4th over 3g to the 6th, all cubed. And what we're going to do is we're going to multiply this number inside the parenthesis times itself 3 times. So this is going to be 5 cubed e to the 12th. Okay, we're going to multiply the exponents over 3 cubed is 27, I think. G to the 18th. When you have a power raised to a power, you multiply the exponents. Okay? But again, don't forget to, 5 cubed, I forgot to do this. 5 cubed, I think, is 125. E to the 12th over 27 G to the 18th. Okay, the only thing you really need to take away from this is when you have a power raised to a power, you multiply the exponents. Everybody got it? Look how old my hand looks. Ooh. Hideous. Okay.
I don't know why my mute keep cutting off. I was asking you to wait.
I'm doing that.
I didn't get to the last part.
I'm doing that because it's somewhat distracting. If you need to unmute yourself, go ahead. Okay. Mm-hmm. So what if we have 3x squared y cubed all raised to the, let's make it the third power so I can deal with it without using a calculator. Oh, that's good. Okay. And remember, we're going to multiply this whole thing times itself 3 times. So first of all, 3 cubed is 27, I think. X squared cubed, okay, we have a power raised to a power. So it's going to be x to the 6th and y to the 9th. Power raised to a power, multiply the exponents. And actually that should be 27 y to the largest exponent first, y to the 9th, x to the 6th. But again, I'm not going to be real critical about this. Okay. Now what if we have this? These problems, they really don't get any more difficult. They just get longer. So if we have 5a squared b to the 5th over c to the 6th. Let's make that 2c to the 6th. All raised to the third power. Now remember, this is kind of like the distributive property of multiplication. The only thing is we're going to distribute the cube, over every term inside of the parentheses. And this is going to be 5 cubed, a to the 2 times 3, b to the 5 times 3, over 2 cubed, c to the 6 times 3. We're going to multiply the 3 to every exponent in there. So this is 5 cubed is 125, I think. A squared cubed, again, we multiply the exponents. A to the 6th, b to the 15th, over, we're going to cube the 2, that's to 8, I think, c to the 18th. Can we reduce this fraction here? I don't think so. Okay, this is really very simple. They just get longer. They really don't get any more difficult. Okay, again, when you have a power raised to a power, you multiply the exponents. Mm-hmm. Okay. Let's see, what else do we have? Now, when we multiplied with a to the fifth times a squared, what did we do with the exponents? We added them. When you multiply, you add the exponents. But what if we divide? What are we going to do here? We're going to subtract the exponents. So if we have b cubed divided by b squared, this is going to equal, b cubed is b times b times b, right? Over b times b. Now, any number divided by itself is 1. So we can pretty much just eliminate those two. And what do we end up with? B. 3 minus 2. Okay, this is going to be b to the third minus 2, which is 3 minus 2 is 1. Okay, now what they're going to do on the test, and I'm going to do this too, is say evaluate V-A-L-U-A-T-E with all positive exponents. Evaluate with all positive exponents. Because if we had c to the fifth over c to the seventh, what would we have here? We have 5 minus 7, so that would be c to the negative 2. Well, this is not a positive exponent. This is going to be equal to 1 over c squared. 7 minus 5. But how many? There's 7 c's on the bottom, on the denominator, and 1 in the numerator. So we're going to subtract them. But the majority of the most variables are on the bottom. And we'll learn how to deal with this in just a minute. Now, remember we said any number to the 0 power is 1. Now we'll prove that here. If you have a to the fifth divided by a to the fifth, what do we do with the exponents when we divide? A to the 5 minus 5, which is a to the 0, which is 1. Or you can think of it like this: 2, 3, 4, 5 over a. Okay, any number divided by itself is 1. Okay, a to the fifth divided by a to the fifth, these are exactly the same numbers. But when you divide any number by itself, any number divided by itself, the answer is 1. Okay. And again, if we have x to the fifth over x cubed, we're going to subtract. Now most of the x's are on the top, right? So it's going to be 5 minus 3 is going to be x squared, 5 minus 3. Okay, when you divide, you have the same, you have a common base number. Subtract the exponents. Oh, that's good. And again, if we have a cubed over a to the 7th, okay, we're going to subtract the 2, but where are the most a's? They're on the bottom. A to the 4th. The difference between 7 and 3 is 4. You have to have a 1 in the numerator there. Right, right. Is everybody okay with this? Can we move on, or does anybody need more?
I'm
Okay.
good.
What? I didn't hear you.
I said I was good.
Okay. Okay. Now, what if you have negative exponents? Remember, if you have a negative exponent, it's real simple how to deal with it. Now, remember that the instructions will always is a long time, but they typically want all positive exponents. All positive exponents. So what if you're given this? C to the minus 3 over D to the minus 2. It's just real simple. If the exponent is negative, move it. If it's in the numerator, move it to the denominator. If it's in the denominator, move it to the numerator. So this is going to equal, tell you, I'm stupid and I have to draw the line. And take them one at a time. C to the minus 3, where does it go? To the bottom. And it becomes positive. D to the minus 2 goes to the top, to the numerator, and the exponent becomes positive. Just like magic. Okay. And if we have a to the minus 5 over b to the minus 3. Now again, I do this so I don't get confused, because I'm stupid. Okay, take them one at a time. A to the minus 5, where does it go? To the bottom. Because you have a negative exponent here, so it goes to the bottom and becomes positive. Right? B to the minus 3 goes to the top, and it becomes positive. Now again, these problems, they don't really get any more difficult, they just get longer. So that's why I'm saying to draw the fraction bar first. Excuse me. Draw the fraction bar first. Take these numbers one at a time and move them if you have to. And you have to if the exponents are negative, because again, the instructions say evaluate with all positive exponents. So what if we have this? What if we have 5 to the minus 3 over 5 to the minus 7? So this is going to be 5 cubed. In the denominator, the exponent's negative, so we move it to the bottom. This exponent's negative, so we move it to the top. Now we have a common base number, so we subtract the exponents. So this is going to be equal to 5 to the 7 minus 3, 5 to the 4th, which is, I think it's 625. But who knows? I'll tell you who knows. The calculator knows. Can y'all see this? First thing you turn it on. Where's the on button? Okay, we want 5 raised to the 4th power. 5. You see this thing right here? Looks like a little hat. That means raised to the 4th power. 5 raised to the 4th power is, yep, 625. Mm-hmm. Okay, what if we have this? M to the 5th divided by m to the minus 2. Draw the fraction bar. Where does m to the 5th go? It's positive, so it stays. M to the minus 2 goes to the top. Over 1, we don't write, you don't have to write the 1, it doesn't really mean anything. Equals m to the 7th. Okay, this is kind of part and parcel of the reason that we draw the fraction bar first. Kind of help you to kind of sort these things out. Okay. Let me do another one of those. If we have e to the minus 4 over e cubed. Draw the fraction bar. Now where does p to the minus 4 go? To the bottom, because it's good. It's negative. So it's p to the 4th times p cubed. You have to have a 1 in the numerator. Equals 1 over p to the 7th. Right? Right. Okay, now what if we have this? 5t to the minus 3rd power. Now remember, the negative 3rd power only goes to the t. It doesn't go to the coefficient there. So this is going to be equal to 5 times 1 over t cubed. All right, this is actually over 1. We just don't write it. But you have to get that into the t to the minus 3 has to get into the denominator. So this is going to equal, and that's actually over 1. So this is 5 over t cubed. Let's see.
Wait a minute.
What?
But can you back it up to that last one?
Sure. If we have 5t to the minus 3rd power, okay, this actually equals 5 times t to the minus 3. The 5 has an exponent, but it's 1, we just don't write it. So this is going to be equal to 5 times, now how do we get that? How do we get this exponent to be positive? Has to go to the
to the bottom.
good. Very good. And don't forget there has to be a 1 in the numerator. Now 5 is actually 5 over 1. Now we multiply straight across and we get 5 over t cubed.
Got it.
Okay?
Thank you.
Sure, thank you. Please ask questions if it doesn't make sense. Am I going too fast? Okay. Okay, now this is more like what you're going to see on the final exam. You're going to think, holy moly, I can't do this. This is way too hard. My brain collapses when I see these. But take them one at a time. They're really not that difficult. So if we have 7x to the minus third y squared over 2x squared y to the minus fifth. Look, you've got positive and negatives all over the place here. This is why I think, anyway, it's kind of important to draw the fraction bar first. Now let's go right down the line. 7. What's the exponent there? Positive 1. So 7 stays at the top. X to the minus third goes to the bottom and becomes positive. Y squared is already positive, so it stays where it is. Everybody with me here? 2. The number 2 has an exponent of 1, positive 1, so it stays where it is. X squared is positive, so it stays. Y to the minus 5 goes to the top. We have 7 over 2. Now, this gets back to the product rule. We have the same base numbers, and we're multiplying here. So what do we do with the exponents? Add them. So y to the 7th. Same thing on the bottom in the denominator. X to the 5th. Okay, these are real simple. Just remember, if the exponent's negative, move it. If it's positive, keep it where it is. And then you'll have the product rule where you have the same base numbers. So you add the exponents there and there. And like I said, these problems, they really don't get any more difficult, they just get longer. So if we have 3a to the minus 2, b to the third, c to the minus 4 over 4a cubed, b to the minus 5, c to the minus 6. Well, like I said, these probably don't get any more difficult as you get longer, is all. Okay, so 3 stays where it is. A to the minus 2 goes to the bottom. Oh, let me put the 4 down there also. A squared. B cubed stays where it is because it's positive. C to the minus 4 goes to the bottom. Am I going too fast? Everybody okay? Okay.
Yeah.
C to the minus 4, when the exponent's negative, move it. Now we go to the denominator. A cubed stays where it is. B to the minus 5 goes to the top and becomes positive. C to the minus 6 goes to the top and becomes positive. Now let's clean this misery up some. Have 3 over 4. B cubed times b to the 5th is b to the 8th. Right, we have the product rule. when we have the same base number, add the exponents, and c to the 6th. Okay, now we have an a here and an a here. That's going to be a to the, what is that, 5? And
Yeah.
c to the 4th. Now, we have c's in the numerator and denominator. B to the 8th, c to the 5th. Now we have the quotient rule, or when we're dividing. When we divide, what do we do with the exponents? We subtract them. Now there's more c's in the numerator. There's 6 here. 6 minus 4 is c squared. And I think that's all we can do. Wait a minute, what is this? It's supposed to be an a. Stupid boy. I'm sorry, I'll do better. In fact, we had a squared and a cubed was a to the 5th. Everybody got it? Okay. Okay. What if we had d to the minus 3, e to the squared, g to the minus 4 over g squared. Wait a minute, I got to itch my eye. I got some itchy scratches. D to the minus 5 and e to the minus 3. Again, you see this, you think, holy macaroni, I cannot do this. Yeah, you can. Take them one at a time. D to the minus 3 goes to the bottom. E squared stays because the exponent's already positive. G to the minus 4 goes to the bottom and becomes positive. Don't try to go too fast on these because it's easy to get mixed up. Now we go to the denominator. G squared stays because it's already positive. D to the minus 5 goes to the numerator and becomes positive. E to the minus 3rd goes to the numerator and becomes positive. Now let's clean this misery up. We have e squared here and e cubed here. So that's going to be, okay, that's going to be to the 5th power. D to the 5th, when we have the same exponents, we do alphabetical order first. So it's d to the 5, e to the 5 over g to the 6th, all right, 4 and 2, d cubed. Is there anything else we can do here? Yes.
Reduce.
Good. Reduce the d's, right? 5 minus 3 is 2, so d squared e to the 5th actually should be reversed, and g to the 6th. Anything else? Should be e to the 5th d squared, but who cares? Okay. Now this is about as difficult as these get. If you have a to the 4th, b to the minus 2 over b to the minus 2, a to the minus 5, all in parentheses, raised to the negative 3rd power. Now, this is the power rule. When you have a power raised to a power, You have a power raised to a power, you multiply the exponent. It's going to be a to the negative 12th, right? 4 times negative 3 is negative 12. B to the negative 2 times negative 3 is a positive 6 over b to the 6th, a to the 15th. Right? Look, b to the 6 divided by b to the 6, any number divided by itself is 1. So we can just eliminate those. Now, a to the minus 12, where does it go? Goes to the bottom. Good. A to the 15th. Don't forget, you have to have a 1 in the numerator here. So now we have the product rule. When you have a common base number, what do you do with the exponents? Add them. 1 over a to the 27th. Okay. This is about as difficult as these problems get. You might see them a little bit longer than this. On the final exam, you might have 3 numbers in the numerator and denominator, but that's really all there is to it. It's basically the same thing. Did everybody see the power rule here? When you have a power raised to a power, you multiply all of the exponents. Okay? And watch for the signs. Any questions?
Would we multiply it by the base?
Say that again?
That if it's this negative 3, if you had like say 5a, we don't multiply the negative 3 to the 5, right? The base.
Yes. Oh, very good. Yes. Excellent question. What if we had this? What if we had 5a to the negative 3rd power over 2b to the negative 6th power, all raised to the negative 2? Yeah, thank you. Remember, the exponents on the numbers are 1. We just don't write them. So this is going to be equal to 5 to the minus 2. A to the negative 3 times negative 2 is a positive 6. Can y'all read this? Just trying to write so fast. It'll be 2 to the negative 2, okay? And b to the 12th. So this is going to be equal to, now, both these exponents are negative, so it's going to be 5 squared, 2 squared, right, because the exponents are negative, a to the 6th, b to the 12th, so it's going to be 4a to the 6th over 25 b to the, well, thank you very much.
That one gets me a lot.
Yeah, it does me too, to tell you the truth. But just don't forget the numbers have an exponent too. We just don't write them because we're lazy. Some of us are lazier than others. Y'all stop looking at me. Everybody okay with this? Okay. If you haven't done your test, you have 3 hours and 30 minutes to do it. Unless you have a really, 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 really good excuse. Gosh, I had somebody in my other class, I wrote to them and said, why haven't you done your test? I tried to be a little nicer than that, but why haven't you done your test? She said, this person said, I just became homeless. Can you believe? We think we've got problems. Golly. So I did give her extra time. But anyway, any questions? Okay, we're going to review this stuff over the course of the rest of the semester. We'll review it several times. I know there's a lot to take in here.
We have a quiz that's opening up tonight.
Yes, sir. It's open up right now.
All right.
I think it's quiz number 8.
8. All right.
I didn't write it down. I'm sorry. I'll do better.
It is quiz 8.
Is it? Okay, thank you. Okay, I'll see you. What is today? Is it
Tuesday.
Thursday? Oh, it's Tuesday. You sure? Okay,
Yep.
I'll see y'all Thursday. And if you're good, you won't have to come to class next week at all. Y'all realize we're almost halfway finished with the semester. They go by fast, don't they?
Go by fast.
They sure do. Well, y'all take care. I'll see you Thursday.
Thank you, you
All right.
too.
Thank you.
Bye.
Bye-bye.
Bye-bye. Bye, everybody.
Mr. Moore said goodbye, everybody. Smack them around some.